to. Did it start?
Yeah.
Okay, okay. So we had this information with the size of houses, the selling price, and we saw that there was a strong positive linear association. Our R value was like 0.9006 or something. 0.9 is strong. The closer to 1 you are, the stronger it is. So if you have a strong relationship, then you can find a regression line. You're finding a line of best fit is what a regression line is. Now, the technical name for it is called the least squares regression line. And what it actually is doing is figuring out the line that fits the best as far as how far apart the points are, the scatter plot is, from the line. So there's two options here. Which one is the better fit? The left one. And if you look at the differences between the point and the line, these are very small distances. These are big. So what the calculator does is it finds the least differences. So least squares just means it's finding the least differences between the points and the line. It really doesn't matter. So if you just see least squares regression line, you're just finding the regression line. That's all we're doing. Now, there's two ways we're going to find the regression line. Sometimes we're given the table of data. Makes it super easy. And sometimes we are given some information and we have to use a formula. Oh, no. So we need to be able to do it both ways. So the equation of the regression line, the first way we're going to find it is by being given some information. We're going to be given sample means. So the sample mean of the x's, the average of the x's, sample mean of the y's, the average of the y's, and then the sample standard deviation for the x's and the sample standard deviation of the y's. We also need to know the correlation coefficient R. So the equation of the regression line for predicting y values, that's what it's used for, is, and they put this little y with a hat on it. We call that y hat. It's a little thing. Y hat, that means we're predicting y's, equals b sub 0 plus b sub 1 times x. So this is the equation of a line. What is usually the number in front of the x in an equation of the line? Slope. It's just written in a different order than we're used to. They put the y-intercept first, then the slope, then the x. So the b sub 1 is the slope. That b sub 0, the number by itself, that is the y-intercept. Now, the variable we want to predict, in this case, we're predicting the selling price, is called, I want to make sure I get my spelling and all that right. So it's called the outcome. I can spell outcome. Or response, because it's what we're predicting. It's the outcome. The variable we are given is called the explanatory, or sometimes it's called the predictor, because it's predicting our outcome. In the equation of the least squares regression line, the explanatory variable, or the one that we're using to predict, would be our x, and the outcome would be our y. Yes, very hard stuff. Now let's pretend we don't have the table there. Let's pretend we're only given the following information. We're going to be given the mean of the x's, the mean of the y's, the standard deviation of the x's, the standard deviation of the y's, and our R value. So on some of the homework problems, they just give you this information and say, find the equation of the line. Ugh. So we got to use these formulas. Oh no. Okay. So the first thing we're going to find is our slope. It's always a good place to start. The formula for slope was, they call it B1, that's okay, is R times SY over SX. Standard deviation of the Y's over standard deviation of the X's. So that's kind of the average change in Y over the average change in X. Does that make sense for a slope formula? Yeah. All right. So we need to find, we're going to take that 0.9006 times the standard deviation of the Y's, the change in Y's, over the change in X's. So let me grab mine. Let me get back to, just a calculation window. And I'd already done that a little bit earlier and got 0.0992. Forgot I'd already done it. Okay. 6 and 4. Okay. Now, we also need our y-intercept to write the equation of the line. And they call that B sub 0. Now, to find the y-intercept, they take the average of the y's minus this B1. What is the B1? The slope. We just found that. So this is going to go right where that is. So we're going to take the average of the y's, the 447, minus our slope times the average of the x's. Now, when I type this in, I just did my slope. So if I wanted to be extra lazy, I could just arrow up and copy the slope so I don't have to retype it. Times 2891.25. And I get 160.19. If you use the 0.0992, you might have gotten 160.188. They both round to 19. Now, there's two ways you're going to see this equation written. This textbook likes to use this format. It puts the y-intercept first, then the slope. So it would write it the y-intercept first, then the slope times the x. But there's another way to write it. How else could we have written it? Yeah, you could have done the what we would think of as mx plus b, right? And do it in the other order. Be really careful about the order. So, especially on multiple choice, you should be able to look at the answer choices and see which order they put it in. Be careful, because they will try to trick you up. They'll switch the numbers around. And see if you're paying attention. Now, that's the long way. What if we were given the table? Yeah. So let's do it that way too and compare our answers. So where would I go to put all of that in to get a regression line? Regression. This is also where you went to find that correlation coefficient in 4.1. So same process. We're going to go in there. We're going to type in our x's in x1. And then our y's in y1. Be really careful typing them in. If you type it in wrong, the answer is not going to be right. Okay. Now, our first thing we can do is go and look at the graph. And guess what? We can do everything from here. On the graph, first off, it tells me the mean of the x's, the mean point, the mean of the x's is 2891.25. And the mean of the y's was 447. That matched what I just put in. If I press OK here, let me actually back out and turn that off because I want to redo it with y'all. Mine was already set up. When I go to the graph and press OK, it gives me a whole bunch of options. The first option and the second option both say linear. The first one says AX plus B, and the second option says A plus BX. So be careful, the order is going to be different. So I'm going to pick the A plus BX so it matches that equation. Now, I go here and I just see the line, but I don't see an equation. Actually, all I have to press is OK. Watch this. When I press OK again, it gives me my equation there. Now it gives me the R squared. If I was trying to find R, remember, where would I go to find the R? Stats. Now, if I go on the stats, I will find the R value. And it also gives me the coefficient, the A and the B, gives me the equation right there too. But I like finding it on the graph because it's right there. 160.19 plus 0.0992, and then there was be an X at the end. It gives me all of that. Are we okay on how to find it? Okay, so if you just press OK, that's the fastest way to get the line. Now we need to be able to use the line. So this line is used to make predictions. That's why it's got a Y with a little hat on it. That just means we're making predictions for Y. We're predicting Y. So we can use the least square regression line to predict the value of the outcome by substituting a value for the explanatory variable. So what if we wanted to use that regression line to predict the selling price of a house of 2,800 square feet? That means X is 2,800. There's two ways you can plug this in. You can plug it in by hand. Or if I keep going down, so this was from the graph, I pressed OK. If I keep going down a little bit further, it says predict Y given an X. There's also an option for find X given a Y. We want to predict a Y given an X. So I'm going to press OK there. And we want to predict the X value of 2,800. When I go to the next screen, it says X is 2,800 there, and it gives me my Y hat. In other words, my estimate for Y of 437.948. Does that mean $437? No, what was that price in? Thousand. So this is $437,000. $437,948. So I can predict the price of an individual house. I can actually use it also to estimate the average price for a house that size. It's going to be the same thing. It's predicting the price for any house that size. So if we wanted to estimate the average price for all houses whose size is 3,000 square feet, this line can also do that. So if we wanted to find the average price for all houses that are 3,000 square feet, we would just go in and plug in. Whoops, you got to delete it first. 3,000 And at the bottom, it tells me y hat is 457.788, which would be how much money? Yep. Isn't that a lot nicer than plugging in by hand? Copy, pasting, and all that stuff. Okay. The last thing we're doing today is just interpreting our slope and our y-intercept, and we're done. Told you it was a short day. So we got to interpret our slope and our y-intercept. So first, let's start with the y-intercept. A y-intercept is the point where the line crosses the y-axis, and it really only has practical interpretation when our data contains both positive and negative values of x. Do we have negative values of our x? No. So it's really not going to be the best interpretation, and let's see why. Okay, so where we cross the y-axis is when the explanatory variable is 0. So when x is 0. What did our x represent? But what in this situation? Square feet. So our y-intercept means when the house is 0 square feet, the price is, what was our y-intercept? Our y-intercept was 160.19, $160,000. Is that a reasonable interpretation that the house would be 0 square feet? So this is not reasonable. Make sure you pay attention to whether your answer is reasonable or not. A lot of times you'll have a real life situation like this and the y-intercept comes out negative. Ooh, that would be even weirder, wouldn't it? So be really careful on the interpretation of the y-intercept. Now, slope is a little bit easier to understand. Slope. The x values are differing by 1. If they differ by 1, then the y values differ by the slope of the line. So in our case, our slope was 0.992. I'll just go to 0.0992. I'm going to go 0.099. That's a horrible way to write it. Let's try that again. Okay, so the way we would interpret it is as the x value increases by 1. So in our case, that would be as the size of the house increases by 1 square foot, the price of the house, is the price of the house increasing or decreasing? The price of the house increases by, yes, $99. It's not 99 cents. Please don't, yeah, $99. Because that would be 0.099 thousand, which would be $99. Now let's see if we can use that to go a little bit further. Let's say 2 houses are up for sale. One house is 1,900 square feet. The other is 1,750 square feet. By how much should we predict their prices to differ? So how far apart are their prices going to be? So let's see how far apart their square footage is. So their square footage differs by 150. So that's the change in square feet. What would be their change in price? So for each square foot, the price goes up $99. So 150 times 99. What is it? 14,000? $850 difference. Does that make sense on how you can use the slope to estimate the changes? So remember that slope is for each one change in X, that's how much the Y is changing. That's all we're doing. So again, if you wanted to find that R value, that was on the stats page, but everything else can be found on the graph page. And we are done.